Let's start our supervised learning algorithm series in which we will talk about the regression problems which we will solve today with the Lasso regression algorithm. Before talking about the technical definition of the Lasso regression, now we will talk about the basic fundamental objective of the Lasso regression. Okay, so now I'll just take a quick example in which we will take a scenario. Let's say we are planning for a trip and we are just packing our baggages, okay, and we are going by flight, which is keeping a limitation of 15 kgs only you can carry along with you, right? So what you will do is you just try to minimize the stuff, whatever is less important or which you can avoid in the trip. So that way you can manage your luggage weight. Okay, so just relate this example with the Lasso regressions. Okay, what it will do is here the Lasso regression will act like a friend which keeps on reminding you that just keep out the unnecessary stuff so that your charges which can be applied if you are going beyond the 15 kg can be applied. So just try to reduce those extra luggage from you, okay, and take the only the essential one, okay, the essential stuff which is required. Okay, the same way what the Lasso regression will do when I'm talking about in terms of the um, supervised learning algorithm, what it will do is it will try to remove or eliminate the less impactful features while building the model. It will shrink the size of the number of features, okay, so that only the impactful features can contribute while building the models, right? So that's what the basic core understanding of the Lasso regression is all about. Okay, now let's talk about the technical terms of it. Okay, so Lasso regression, when we are taking, so it stands for the least absolute shrinkage and the selection operator. Okay, so its major focus is to build a model by picking only the important features, by shrinking, or by, you can say, by removing the less important features. Okay, so how it can do is it automatically reduces the overfitting, okay, and removes the less important features. Now as far as the formula is concerned, we can say that it will minimize the loss by predicting the error plus the alpha into sum of the coefficients, where what the alpha represents here is the penalty. Okay, alpha represents here the penalty which can be caused when we are talking about minimizing the errors. If the alpha value is higher, so it means that the more coefficients go to the zero value. That means more features will be reduced to the zero level. That simplifies the model ultimately. Okay, so that is the basic and the core understanding of the Lasso regression. Now we just move on to the things like how we can take it as a summary. So Lasso regression, we just talk as the example we have taken. So smart packing, it helps us build a lighter, simpler and faster model. Okay, so smart packaging, that means ki whatever be the features we are taking, if it is be on the minimal side, we are taking only the essential ones and then we are making the model out of it. So that will be a fastest way to build a model. So, and along with this, we are avoiding the overfitting here. Okay, so just quickly start with building the model using the Lasso. So first we will import all the essential libraries because we are talking about the Lasso. So we are just importing it. Trains test split library we want because we are working on the prediction model. And the data set what I am taking here is the California housing data set I am taking for this example. Okay, so for finding out the error value, I'm using the mean squared error, okay, and these are the basic essential libraries for this. Now let's start by picking the data set. So here I'm just fetching the California housing database here in the data frame, and now we are just picking all those values. Now either here the data set is with me, I'll just convert it into a data frame. All the features columns will be there. Now I'm splitting it into the targets. So target, I'm specifically mentioning BF target is all the targets which are mentioned in the California database. It's stored here. X and Y are the two things I'm mentioning here. X represents the features and Y represents here the target. So X represents here df California dot features name. So here my features are there. Y represents my target. Now till here I'm ready with my model basic definition. Structuring is ready. Now I want to now split the X and Y into the test and the training set. So for that I'm using train test split function. X and Y are the features and the target I'm using here. 80-20 is the split I need, and the random state is 42 I'm giving. So now I'm ready with the train and test data here. Now here is the thing which we need to understand. Now here I am creating the lasso model. So what I am doing is lasso, in the bracket I am mentioning alpha equals to 1.0. That means alpha, this is, as we just now discussed, this is the penalty. Okay. So this is the penalty which we are imposing to the features while selecting them. Now we will see it in the detail. Now here, once my model is defined, I'm just fitting is my model with the train data. So X train and Y train I am mentioning here. Then I'm just predicting the X test. This is the test data. So I'm passing all the test features and trying to predict the target for that. Now my prediction is done. I'm just trying to see how my model has performed. I'm just trying to see the MSE for this. So Y test and Y test predict. These are the two variables on the basis of which I'm just trying to see the accuracy or the error value. So MSME will give me the answer for this. Now you can see mean squared error is coming 0.9 here. And along with this, the lasso is able to give us what are the important features we can carry along with this model is. Now here I am just printing all those lasso features. Now you can see here what it will do is, from this for loop I'm just printing the features and the coefficients of each of the feature which is coming after the penalty which we are imposing on the model. Now see, these are the coefficients which model has selected. It is coming to near to 0. Okay, that means these are the sum of the features which is coming closer to the 0 by the lasso regression algorithm, and which says that these are not so important for the model building, right? So now you can see alpha plays an important role. Where I'm getting the MSE, the error is 0.9. Now in detail, let's see what are the different value of alpha will represent. Now see here, I'm just writing different values of alpha here. Right now what we have put the value is 1.0. Now this is the 1.0, that is the moderate penalty I'm putting on the model. It will shrink or eliminate more models, right, for building the models. If I'm putting alpha equals to 0, that means there is no penalty, no any features will be eliminated at that state. If we want to remove a lesser features, we can set it to 0.1. This is a weak penalty, okay? And if we want to go on the higher side, that means 2 or more we can set, okay? So here the value of alpha is very important when we talk about the lasso regression. Now let's see this thing by putting the alpha value is 2.0. Now Code is same. I'm just changing the alpha value. Here I'm putting 2.0. Now you can see when I'm running the results, it is showing me the error is 1.3, right? Let me just run all those cells. Let me just run this again. Okay, 0.9 I'm getting. Here I'm making changes. 2.0, so that is coming 1.3. Okay, so now we can see there is a change in the error value, there is a change in the variables, also the features, right? Now one more way we will do here, what we will do is we will see that how we can find it out the best, okay, the best alpha value, so that my error can be reduced. Okay, so what I'm doing here, I'm just doing the cross validation. Here I'm giving 5 cross validation values. So now I'm putting here the CV equals to 5. After applying this cross validation, what I'm getting is I'm getting the best alpha value, which is coming 0.03. So you can put alpha equals to 0.03. Now let's see what will be the impact of it. Okay, so again I'm just combining all those things. Now here we are getting the clear value of the best alpha value. Now I'm just making a complete wholesome solution where we talk about how we can take the best alpha value, how we can compare it and see the visualization of it as well. Okay, now here the all imported libraries are there. We are defining the model with the same data set. Yes, we are doing the cross validations also, and we are calculating the MSE value for this so that we can understand the error value, right? Now here I'm just plotting an interactive plot so that you can able to understand how my alpha affects the error value, that is the MSE, right? So I'm just putting some visualization so that it should be easy to understand. Let's just move on to this. This is the result of my this logic that talks about building the lasso regression model, putting a cross validation of 5-fold, getting the MSE error, and now I'm just putting a explanation on top of it. You can see this is the my mean square error. This is the alpha value. Now we can see how the alpha value will change my MSE error. Now see, when I'm talking about 0.03, this is my alpha value. At that moment, I am getting an MSE error of 0.54. As I start increasing my alpha, now you can see the MSE error will also start it increasing. Now at that point, now you can see here at this point when my alpha is 14.8, I am getting the highest value is 1.3. So this is the way you can understand which alpha value should be taken while building the regression problem, specifically for the lasso regression. Okay, so through cross validation we can identify. Okay, so this is the way we can do the things, and yeah, this is few explanation I'm writing. So it gives us the best alpha or the penalty strength that minimizes the prediction error or balances the model accuracy and get it simplified. Okay, so now here I am getting the best alpha value that is coming through the cross validation, and we have just seen it is 0.034. So I'm just applying here the alpha value that is just now we got it, and now you can see that I'm getting this error value. This is mean square error. This is 0.5. Okay, earlier I am getting 0.9. Okay, so if you have selected the alpha value correctly, definitely we will be getting the correct model, and these are the features we are eliminating with this. Okay, so this is all about the lasso regression. We have seen with a very basic real-time example of it. So in this way you can solve the regression problem. Okay, I hope this is clear to everyone, and keep watching this for our upcoming algorithm for the regression models, and please do subscribe the channel and like it. Thanks.